Okay, here for something a little different, we're going to be doing a Nerdle. So Nerdles are just like the Wordle sort of setup. You put in the numbers and letters and whatnot, and it tells you if it's there, it's not there, or if it's in the right position. So I did figure some things out. So for instance, I can do 8 divided by 0.4 plus 5 equals 21. Equals 7, right? Yeah. So that gives me half of the letters, and in this case tells me it's a single digit. Oh, and it equals 7. Well, that's even more convenient. And then for the other letters and numbers and symbols, I have 9 times 3 minus 6 equals 20. Equals 21. Now the nice thing with this is, the other nice thing is I can go in here and click buttons. So I can say 9 times 3 minus 6. So you can go in and actually click on the individual item, which is very nice, very helpful. So, but yeah, so this, if for instance that hadn't been in that one spot, it would tell me if it was in the other spot, and if it was in neither of the spots, I know it's a 3-digit number. So, okay, so in this case, we know it equals 7. We know there's a 0, a 4, a 3, and a 1, and it's just a division thing. How many numbers is that? 1, 2, 3, 4, 5, and it's going to be 1, 2, 3, 4, 5. Okay, so we only can use each number once. So we know where the 7 is. So it's going to be a 2-digit number. So for instance, we know that this is going to be a divide. And, I guess we don't technically know. We know it's at least a 2-digit number to begin with. And it's either going to be something like that, or I suppose it could be like something like that, like a 3-digit number divided by something equals 7. And that would make probably more sense given that there's a 0. And the only other even number we have is a 4. So it'd have to be a 20 or a 40 or an 80 sort of for that to work out. So it's probably not a 0 situation. Okay, so 7 times what? Because we need to figure out these spots here. So 7 times what equals, so one of these numbers. So 7 times 1 would give us 7, except we know it can't be a 7, right? 7 times 3 is 21. That's an option, because we have a 1 there. So it could be like a 1 and a 3. So that's a possibility. If that's the case, then that has to be a 2 here. Except we know it can't be a 2, which means it would have had to be a 3 that we borrowed from, and we can't have 2 3s. Okay, so that does then seem unlikely that it's a 3-digit divided by a 2-digit. Right, there's nothing else. 0 wouldn't work, and 4 is an 8. Okay, yeah, so it's got to be something like that, which makes this all the more difficult. Wonderful. Okay, so that probably means that the 0 is there. Except it has to be a full number. So if this was 30, nope, 4 doesn't go into 30. Wait, maybe I'm wrong. Let me just see something here. 4 and a 1. Okay, so if it's this arrangement, we only can use each letter once. If it's the other arrangement, the other arrangement, we have an extra letter we can play with, which means it could have been a 7. Ooh. Okay, let's just figure this out first. Is there any way with a 3, 0, and a 4 we can equal a 7? Because 7 divided by 1 would be 7. I don't think so. 43, 3, 0. No. Okay, so then we're back to our original idea of this. So 7 times something equals... I might just have to figure out some placement, because right now we don't... All we know is this spot here is not a 3 or a 0, and that's really the only information we have. So 7 has to equal 7. Okay, so the first number's got to be fairly high. I mean, actually, no, it doesn't. It could be a 1. So 7 times... What did I say? 7 times... Oh, no, because we needed that 1 here. So if we do 3, 7... So that equals a 1. Right? Yeah. So that's the 2. And then we got to bump that up to a 3 somehow. Which means whatever is here, we have to borrow from in order for it to work. So 4 maybe? So that make it a 14. 14. What number do I have left? A 0? That's not right. It's 21. Well, shoot. Okay, so that's probably not it then. I mean, it could also be a 1 there, which makes that a 7. Except the fact that whatever number it is has to go into it 7 times. So this is going to be like a 4. So like 41 goes into... No, because it's 28, 7. That would still be... So it would be 70... Wait. 41 times 7 is 287. Right? I mean, we don't have a 2 or an 8. Yeah. Okay, so how do we adjust? We have to adjust the number. 7 times 1. Sometimes these are easy. Sometimes these are a little bit harder. Okay, so 7 times 1, that can't change. We can change the 4 to a 3. Does that help? That's 21. But we needed a 4 in order for that to work. And a 0, which we're not getting. Again. Yeah, I just need more information. Okay, so let's try... Okay, we need to figure out where the division spots are, as well as where some of these numbers are. So, let's say 40... Nope. Let's say 40... 3 divided by... that's a prime number. That's not going to work. Okay. How about 44 divided by 1 divided by 4? No, that equals 11. That's too many numbers. Okay, so 44 divided by, let's say 04, because we know the 4 is there, right? Equals 11. Okay, so those last 3 digits, unfortunately, are throwaway numbers, because we know exclamation mark, we know the 7's there, and we know for a fact that third digit is not an exclamation mark. But that's going to tell us, hopefully, where at least the 4 is, as well as if the 4 is one of our double-digit numbers. It also tells us if 1 is one of our double-digit numbers. So let's see what happens. Okay, so we know where the 4 is now, at least. And we know there's only a single 1, and there's only a single 4. Which means either our 7 or our 3 or 0 is the duplicate. So now we know for a fact that that's a 4. We know that's a 7. We know that it's an equal sign. Nope, that's an equal. Delete that one. That's an equal sign. Okay, so that's what we know for a fact. We also know it's not a 3-digit number, or we know it's not a 2-digit number division. We know it's a 3-digit number divided by a 4. So 7 times 4, we know, is 28. So, except the fact that we don't have a 2, and we don't have an 8. So that means this has to be a 3, right? Doing math backwards is difficult, which, I mean, is kind of the point. Especially doing it while recording. It's so much easier when you can just stop and write things down, and instead of trying to do this all in my head. So, for all you math people out there, I apologize. I'm playing this while I'm waiting on a video to render here. Okay, so we know it's a 3, and we know it can't be an 8, so that means it's got to be a 7? Can that be right? That would give us a 2 7s. Okay, so 370 something divided by 40 something has got to equal 7. We know we still have to use a 0, and the 0 can't be there, so let's throw it there for the time being. Except 7 times 0 is 0. Right? So that... we can't divide by... oh, dear me. This is not an actual math equation, right? Am I not going crazy? So if that can't go in evenly, that means there's something wrong with all of these numbers here. Oh, and well, no, we weren't using a 4. So we have a 3, a 0, and a 1 left, and then a duplicate number. I mean, it makes sense that it's something like that. But if that's the case, then it's 28, and we know there's no 2 and 8 in this. So that means that can't be a 1. That can't be a 7. Right, and if we swap that around, 7 times 7 is 49. We know it's not a 9. Okay, let's do this. We know for a fact the 7's there. We know if it's a 1, it can't work. Okay, so we know if it's a 0, it can't work. Okay, so that leaves a 3. Actually, it leaves a 3 and a 7. So 3 times 7, 21, right? Which we have to borrow to do, because that's a 21 at that point. We know it's not going to start in a 0, right? 7. Actually, wait, I can just... Okay, 7 times 3 is 21. Carry the 2. 7 times 8... Oh, 3. 301 divided by 43 equals 7. Is that right? Oh. Okay. There we go.